Hello everyone, welcome again to another math online lesson. Our topic for today is the effect of changing the value of a, h, k in the equation y is equal to a times the quantity x minus h squared plus k of a quadratic function on its graph. Okay, so a parabola, this is the quadratic graph of a quadratic function. It's called a parabola. Now, a parabola may open upward or downward. It can also be narrow or wide. It may move from left to right, and it also have a vertical and horizontal translation. Now, to further understand this behavior of the parabola or the quadratic graph, let's have some illustrations. So say we have here the equation y is equal to x squared. This will be the graph of the said equation. Now y is equal to x squared is also called the simplest form of the quadratic equation, whose vertex is at its origin, here, at 0, 0. Now y is equal to x squared is also called our parent equation, and this one is our parent graph. Again, y is equal to x squared is a parent equation, and this one is our parent graph. Now, let's try to see the effect when the value of a changes. So let's use the equation here, y is equal to ax squared. So for this one, y is equal to ax squared, the graph would still be the same as our parent graph. Because from here, from our parent equation, when a is greater than 0 or positive, the parabola opens upward. Here, from our parent equation, a is equal to 1, right? So this one here is our parent graph. Now, what if we have a negative value of a? Say for example, when a is equal to negative 1. But as you can notice here, the equation is similar with our parent equation. The only difference is we have a negative value of a. Try to take a look at the graph of the said equation. So when a is less than 0 or negative, the parabola opens downward. Okay, again, when a is positive, the parabola opens upward. Now when a is negative, the parabola opens downward. Now let's try to see the effect when we tend to change the value of a here. So when the absolute value of a is greater than 1, the parabola appears narrow or compressed. Let's have an illustration here. Again, let's use the parent equation, y is equal to x squared, where a is equal to 1. And the parabola, the parent graph, would look like this. Now say we have here a change of the value of a. We have here y is equal to 2x squared, where a is equal to positive 2. That is greater than 1. Now it says here, when the absolute value of a is greater than 1, the parabola appears narrow or compressed. This is the behavior of the parabola when a is greater than 1. The parabola moves closer to our y-axis or appears narrow. But when the absolute value of a is less than 1 but not equal to 0, say for example here 1/2, this will be the behavior of our parabola. Still, since our a here are positive values, the opening of the parabola still will be upward. But try to take a look or observe the behavior of the parabola. When a is greater than 1, I'm talking about the absolute value of a, the parabola appears narrow or closer to our y-axis. But when a is less than 1 but not equal to 0, the parabola appears wide. Okay? So this is the explanation here. When the absolute value of a is greater than 1 but not equal to 0, the parabola appears wide. Now, same goes when all the values of a here are negative. Say, for example, here from our parent graph, if our a is a negative number, the opening of the parabola is downward. Now, this is still the same with our parent equation and parent graph. Now, when a is negative 2x squared, the absolute value of a is greater than 1, but since it's negative, the opening is downward, but still it is compressed or closer to our y-axis. And also, when a, when the absolute value of a is less than 1 but not equal to 0, which is in this case negative 1/2, so the opening is still downward, but the absolute value is less than 1, therefore the graph is wide. So I hope you notice the behavior of the graph when the value of a changes. If the a is positive, the opening would be upward. If a is negative, the opening is downward. If a is greater than 1, then the graph appears to be narrow, closer to our y-axis. If it's less than 1, but not equal to 0, the graph appears to be wide, away from our y-axis. Now let's try to check the effect when the value of k changes. Let's try to use this equation, y is equal to ax squared plus k. So when k is greater than 0 or when k is positive, the parabola moves upward. And when let me change this one. When k is less than 0 or when k is negative, the parabola moves downward. Again, when k is positive, the parabola moves upward. And when k is negative, the parabola moves downward. Let's try to have an illustration here. Again, let's start with our parent equation and our parent graph. Now, for this parent equation, of course, the value of our k is equal to 0. That is why our parent graph is at the origin. Now, let's try to add a value of our k. So, let's have here y is equal to x squared plus 2. K is equal to positive 2. Again, based on this statement, when k is positive, the parabola moves upward. Let's see the behavior of the graph when k is equal to 2. This will be the movement of our graph. So from here, from our parent graph, since we have a change of value of k here already, it moves 2 units upward since k is positive. Now what about on this case? Y is equal to x squared minus 2. where k here is negative 2. That's negative 2. Let's try to see the behavior of the graph when k is negative. There. So from our parent graph here, since k is negative 2, we then now move 2 units downward. Because this one here, this is our um, parent graph, right? X squared. So this is x squared, the red one. Now, since we have an additional value here, which is the k, and k is negative 2, then from here, when k is negative, the parabola moves downward. So from our parent graph, x squared, we have a change of behavior here. Since that is negative 2, then it moves 2 units downward. Now, let's see the effect when the value of h changes. So let's use this equation. Y is equal to a times the quantity x minus h squared. So here, when h is greater than 0 or when h is positive, the movement of the parabola is going to the right. And when h, again, this is less than 0 or negative, when h is less than 0 or when h is negative, the movement of the parabola is going to the left. So let's have an illustration of this one. Again, let's start with our parent graph or parent equation, which is y is equal to x squared, and the parent graph is this one. Okay, so k here is equal to 0. Therefore, the graph is on its origin. But let's try to have this equation now. Y is equal to x minus 2 squared. Now notice here that the value of our h is positive 2. Why positive 2? Because from this equation, this is already negative, right? So this is h, then this is h. So h is positive 2, not negative 2, positive 2. So since based on this statement that when h is positive, the parabola moves to the right. So try to take a look at the behavior of the parabola at h positive 2. So here, from our parent graph, x squared, so we have a change of h here, which is positive 2. So the parabola now moves 2 unit to the right, since h is positive. Now here, on this equation, y is equal to x plus h squared. That's not plus h, that's plus 2 squared. Again, the equation is y is equal to x plus 2 squared. Now notice the sign here at the center. This is already positive. Now our original sign here is negative. So to avoid confusion, if the sign in between the groupings is positive, then just take the opposite sign of the h here. So that's negative 2. Same as this one. If the sign on the groupings is negative, then take the opposite sign, which is positive. Just to avoid confusion on the value of h. Because this is very important. Okay? So since that is positive, take the opposite sign of this one, that's negative 2. So when h is negative 2, try to take a look at the behavior of the graph from our parent graph here. There. So since h is negative, the parabola moves to the left. Now let's try to check the effect when the value of h, k changes at the same time. Now let's try to use the vertex form of the quadratic function. Y is equal to a times the quantity x minus h squared plus k. Now again, for us to observe the behavior, we have here the parent equation, the parent graph. So say for example here we have y is equal to x minus 2, I mean the quantity x minus 2 squared plus 1. Now we have here, let's try to gather all the data here for us to create our graph. So a here is equal to 1, that's why that's an imaginary number here. Since a is positive, we can assume that our parabola opens upward, right? So here, h, since the sign under the quantity is negative, so let's take the opposite sign of the negative. H is positive 2. Therefore, we can say that our parabola moves 2 unit to the right. K here is equal to 1. Since that is positive, therefore, the movement of our parabola is upward also. So again, so based from this data that we gather, the opening of the parabola is upward, and then from the parent graph, it moves 2 units to the right. And then it also moves 1 unit upward. So let's try to check the final position of our graph on the function y is equal to the quantity x minus 2 squared plus 1. There. So again, from our parent graph, since a is positive, the graph opens upward, and then h is positive 2, so it moves from here, going 2 units to the right, here, and then k is positive 1, then it moves 1 unit upward. So there you go. This will be the graph when the value of a, h, and k changes. So the parabola moves 1 unit upward and 2 units to the right. So let's have a quick example here. Say we have here the quadratic function y is equal to 2 times the quantity x minus 2 squared plus 2. So again, let's gather all the necessary data. First, let's find the value of a, which is equal to 2. Next, find the value of h. So h here, since the sign on the quantity is negative, let's try to get the opposite sign of this one. So we have positive 2. And of course, k here is positive 2 also. So let's try to locate our graph. So if you um, view my lesson on the graph of the quadratic function, h and k here also refers to the vertex, the coordinate of the vertex, or the turning point of our graph. That is the vertex at h, k. There. So from here, we all know that the opening of our graph is upward because a is positive, and then since a, the absolute value of a is greater than 1, so our graph appears to be a bit narrow or closer to the y-axis. So first, let's locate the turning point of the graph. So h2, it means the graph moves from the origin, from its original position on the parent graph. So it moves 2 unit to the right. So here, 1, 2. And then it also have a vertical movement, positive 2, so it moves upward, 1, 2. So this will be the turning point of our graph at 0 at 2, 2. Okay? So all we need to do is to draw the graph of the quadratic. So assume that this is the graph. So it's a bit narrow because A is greater than 1 and it's opening upward. So I hope you learned something today on the behavior or the effect on the graph of a quadratic function when the value of A, H, and K changes. See you on my next online lesson.